Hello everyone, I am Shivani and welcome to Civil series. So here I come with the next part of surveying short notes, and in this video we are going to see each and every important point because each topic is as much as important. So let's start with the first topic. First topic is offset. Okay, so offset is used to measure a distance between object object and survey line. Okay, offset is used to measure a distance between object and survey line. Okay, there are two type of offset. Okay, consider this is a surface. If we measure the distance in a perpendicular direction, so this is perpendicular offset. Perpendicular offset, and if the distance is measured as an inclined form, this is nothing but a oblique offset. Angle other than 90 degree, angle other than 90 degree, then this is nothing but a oblique offset. Oblique offset. Okay, first, if length of that offset is more than 15 meter, then that offset is long offset, and if length of that offset is less than 15 meter, then that is short offset. Okay, this is about the offset. One important point is here that how we differentiate the well conditioned triangles and ill conditioned triangles. So first, well conditioned triangles, and second condition is ill conditioned triangles. Ill conditions triangle. Okay, if angle of the triangle is greater than 30 degree and less than 120 degree, then that condition is well conditioned. If ill condition, if angle is less than 30 degree but angle greater than 120 degree, this condition is nothing but a ill condition, and well conditioned in that theta is greater than 30 degree and theta is less than 120 degree. Okay, then then these are the some instruments to measure the offset. So first is open crosstalk. Open crosstalk is used to measure a perpendicular offset. Okay, used to measure or used to draw the perpendicular offset. Then French crosstalk is used to draw the 45 degree and 90 degree offsets. Then then adjustable crosstalk. This is used to draw any angle offset. Then prism square, this is used to draw the perpendicular offset, and next side square is also used to draw the perpendicular offset. This prism square is similar to optical square. And the side square is the combination of two telescope. Okay, here the open crosstalk, prism square and side square. Prism square is similar to optical square. All the three are used to measure or used to draw the perpendicular offsets. French crosstalk is used for 45 and 90 degree offset, and adjustable crosstalk is used for any angle. Okay, the next is true meridian. True meridian is a fixed line of reference. True meridian is a fixed line of reference to determine the direction of survey line. True meridian is a fixed line of reference to determine the survey line. True meridian pass through or true meridian line in which the plane is passed through north and south pole. And this true meridian is always constant. Okay, then next, magnetic meridian. Magnetic meridian is determined by freely floating and balanced magnetic needle. The direction is determined by freely floating and balanced magnetic needle. Okay, here this magnetic meridian plane pass through magnetic north and magnetic south. Magnetic north and magnetic south. But this magnetic north and magnetic south pole is not constant. Therefore, this magnetic meridian is not constant. Okay. Then next is arbitrary meridian. Arbitrary meridian is any convenient direction towards the permanent mark. Any convenient direction towards the permanent mark. Towards the permanent mark. Okay, so this is about the true meridian, magnetic meridian and arbitrary meridian. Then next is deep. Then next is a deep. Deep is angle between horizontal plane and any magnetic needle. Any magnetic needle. So this inclination is nothing but a deep. Then magnetic declination. Magnetic declination is angle between magnetic meridian and true meridian. So this is what the true meridian and this is magnetic meridian. Angle between true meridian and magnetic meridian is magnetic declination. Deep is angle between horizontal plane and any magnetic needle. Then these are the four terms which are related to deep and declination. First term is isoclinic line. Isoclinic line are that lines in that deep is same. If deep value is same, then this is nothing but a isoclinic line. If deep is 0, then that lines are aclinic lines. If the magnetic declination is same, then that lines are the isogonic lines. And if we consider this magnetic declination as 0 here, then these lines are nothing but agonic line. So this is all about the true meridian, magnetic meridian, arbitrary meridian and deep declination, isogonic, isoclinic and agonic and aclinic line. Then next is, okay, so here the next point is whole circle bearing and reduced bearing. For whole circle bearing, we represent it like a WCB, and this whole circle bearing is also known as azimuthal bearing. Azimuthal bearing. Then for reduced bearing, this is also known as quadrantal bearing. Quadrantal bearing. Whole circle bearing is measured from north pole in clockwise direction. Reduced bearing is measured from north and from south pole in clockwise and anti-clockwise direction, and in case of south pole in clockwise and anti-clockwise direction. The angle range for the whole circle bearing is 0 degree to 360 degree, and for the reduced bearing the angle range is 0 degree to 90 degree. So this is how we calculate the whole circle bearing and reduced bearing. This is the quadrantal system, first chord, second, third and fourth. In that the WCB is measured like this. This is what the survey line. So value for the RB or the WCB here is, okay, consider this as a 110 degree Celsius. The value for WCB is equals to 110 degree Celsius. Consider this as one quadrant here. If we take the same angle as a WCB here, this is what the survey line. For this survey line, the RB value is, this is what, because we measure the value from the south pole in anti-clockwise direction. But here the value of RB is different from the whole circle bearing. So how to calculate the reduced bearing values from the whole circle bearing? We see the formulas one by one. Take a first condition. This is the quadrant system. In that we take an angle in the first quadrant. This is the survey line. Here angle is 30 degree. For the first condition, the WCB value is 30 degree here, because angle present in the first quadrant. And in case of RB, the value is same as 30 degree, because here we measure the angle from the north pole and in the clockwise direction. So value of WCB and RB is same in the first quadrant. Okay. Then second, if angle is mentioned in the second quadrant, take this angle as a 110 degree Celsius. So value of WCB is clear, that 110 degree Celsius. But for the RB, the value of angle is little bit near to the pole. Here the value of RB, north pole is here, south pole is here. From the south pole the angle is little than from the north pole. So that's why we take the measurement of the angle from the south pole. So for south pole this total angle is 180 degree. Okay, so minus the value of WCB from that 180 degree. So here we get the value of reduced bearing. 180 degree minus 110 degree Celsius, which is equals to 70 degree. Okay, this condition is for the second quadrant. This is the formula for the second quadrant. This formula is for the first quadrant. Value of WCB and RB are equal here. Then second condition, if we take the angle in the third quadrant, this is what the angle. Assume this angle as 195 degree. Okay, so WCB value is equals to 195 degree. But for the RB, here RB is measured from the south pole because south pole is near to it. So that's why this total is nothing but a WCB. And if we minus this 180 degree value, then we get the value of RB. So minus 180 degree here. So RB is equals to 195 minus 180 degree. The RB value is 15 degree here. So this is the formula for the third quadrant. Then next, if we take the same condition here, but the angle is in fourth quadrant. Okay, so total angle from the north pole is, assume this value as 295. Okay, then WCB value is 295 here. But for the RB, the formula is, this total is nothing but a 360 degree. Okay, if we minus the 360 degree and WCB, then we get the RB value. 360 degree minus this 295 is nothing but this RB. So this is the formula for the fourth quadrant. RB is equals to 360 degree minus WCB. Okay, so this is all about the whole circle bearing and reduced bearing. The next is fore bearing and back bearing. Fore bearing is the bearing of survey line which is measured in the direction of survey work. Bearing of survey line measured in the direction of survey work. Bearing of survey line is measured in the direction of survey work. Back bearing is bearing of survey line measured opposite to the direction of survey work. Okay, this is what the back bearing and fore bearing. Here this is the one survey line. Okay, so this is the one survey line, and the fore bearing angle is, bearing is measured in the direction of survey line. So this is what the theta 1 value, and bearing is measured in the opposite direction is the back bearing. So this is theta 2 here. For this particular line, this is theta 1, means this is the fore bearing for this line, and this is back bearing for this line, which is theta 2. So how to calculate this back bearing and fore bearing? Back bearing is equals to fore bearing. Plus minus 180 degree. Okay, so how to take this plus and minus here? In case of WCB system, and second in case of reduced bearing system. Okay, in case of WCB system, if the fore bearing is less than 180 degree, take positive sign. If this fore bearing is less than 180 degree, take this as a positive sign here. But this fore bearing is greater than 180 degree, then take it as a minus sign. Okay, so this is how you calculate the WCB. This is how you calculate the back bearing in WCB system. But in case of RB system, okay, if this is the value of the angle in the RB, this is north and this is east. Okay, the angle is, if this angle is 30 degree, okay, north 30 degree east. Okay, one more point is there. Okay, this is WCB system. In that we directly mention the angle as theta is equals to 360 degree, theta is equals to 270 degree. This is in the WCB. But in case of reduced bearing, we represent the angle as north 30 degree east. Okay, so like this, if this is the quadrant, okay, angle is like this is 30 degree, so represent this as north, this is east, north 30 degree east. Okay, if the angle is like this, okay, same, this is the quadrant here. If the angle is like this, so represent it as, this is south, here is the east, so write it as south. Okay, if this is 30 degree, south 30 degree east. Okay, then second, if the angle is like this is the quadrant, angle is in the third quadrant, and this is 30 degree. Okay, this is south, this is west. Okay, represent this as south 30 degree west. Then take the angle in the fourth quadrant like this. So this is near to north pole. So this, if this is 30 degree, represent this like north 30 degree west. So this is how we represent the angles in the reduced bearing. And here the reduced bearing angle is north 30 degree east. And the back bearing in case of RB system is, just take the directions in the opposite sign. This is south, this is west. Okay, south, if this is 30 degree here, south 30 degree west. So this is fore bearing and this is back bearing. So this is how we calculate the fore bearing and back bearing in case of RB system. So this is all about the important points from the surveying, and in the next video we're going to see the leveling, and for this video this is the points, and thank you for watching this video.